Next, we see the construction and working principle of stepper motors. So, stepper motor in the sense we give the electrical pulses as the input, then we get the discrete angular displacement. For this type of stepping motors, we are not giving the continuous supply. We give by using the solid state control circuit by signal or pulses only we give. For each pulse, it produces a one rotation. This is called stepping motor or step motor. So, the number of input pulses and the number of discrete angle steps taken by the motor. So, how many input pulses we are giving into the stepper motor, that is equal to the number of discrete angular steps taken by the motor. So, there is no need of feedback sensor for measuring the angular position of the rotor. So, how many number of input pulses is given, so correspondingly equal to the easily find out the position of the rotor. So, for the stepper motor, we can use the control application as a open loop control, and in this motor there is no rotor windings and commutator brushes, so easy construction, and also it is robust and reliable. And step angle. So, the step angle, what is step angle? The step angle through which the motor shaft rotates for each command pulse is called step angle. For a given electrical pulse, how many angle it rotates, motor output rotates, that is called step angle for each pulse. The step angle is minimum 0.72 degree and the maximum step angle may be a 90 degree. The step angle is calculated by beta equal to ns minus nr divided by ns into nr into 360. Ns is a number of stator poles, nr is a number of rotor poles. So, here beta is equal to 360 divided by nr. Nr is a rotor poles or rotor teeth. M is the number of stator phases, and resolution is calculated by the ratio between the number of steps to the revolutions, that is 360 degree divided by beta, and n, that is the motor short speed, that is calculated by beta into f divided by 360 rps. Here the beta is the step angle and f is the stepping frequency of the input pulses. So, in stepper motor, the speed of the motor is solely determined by the input pulse of the motors, and this is applications of the stepper motor. So, stepper motor used in the larger applications, example computer peripherals, textile industries, IC fabrication, and in robots or robotics, and in incremental type application like typewriters, line printers, tape drive, floppy disk drive, numerical controlled machine tool, so process control applications, XY plotters, and also in commercial, medical and military application like it uses a mixing, cutting, striking, metering, blending and purging. So, this is a applications of stepper motors. This is a one simple problem to find the step angle. It is a hybrid VR. There is a variable reluctance stepper motor has 8 main poles which have been casted to have 5 teeth each. If the rotor has 50 teeth, calculate the stepping angle. So, first we have to calculate number of stator teeth. It have 8 main poles, each have 5 teeth. So, the total number of stator faces, that is equal to 40 and the rotor is 50. So, the beta is equal to ns minus nr, 50 minus 40 divided by 50 into 40 into 360, that is equal to 1.8. This is the step angle of the motor. And then the stepper motor is classified into 3 categories. One is variable reluctance stepper motor and permanent magnet stepper motor, and third one is hybrid stepper motor. Now, first we see the variable reluctance stepper motor. The stator is a wound stator poles and the rotor pole is made up of ferromagnet material, and the direction of rotation is independent of the polarity of the stator current. The reluctance of the magnetic circuit is formed by the rotor and stator teeth varies with the angular position of the rotor. If this is the control circuit for variable reluctance stepper motor. This is the three switches S1, S2, S3. This is the DC supply. Here this is the number of stator phases. So A, B, C, A dash, D dash, C dashes. So the number of stator teeth, that is equal to NS equal to 6. And the number of rotor teeth, that is equal to 4. Then we can find step angle, that is equal to NS minus NR divided by NS into NR into 360. So we can get here 230. So the step angle for a given input pulse, this angle moved by the rotor is 30 degree for this construction. The rotor having the 6 teeth and stator the stator having the 6 teeth, the rotor having the 4 teeth. If this is the control circuit, actually the control circuit is taken off by the solid state control. Here for the understanding purpose we can use the 3 switches, and here the A dash are seriously connected, that is the diagrammatically opposite direction. So here the A dash and BB dash, C dash are seriously connected. If the switch S1 is closed, the coil A and A dash is energized. So it offering the low reluctance path. So the rotor moved to the align with the positions of A dash. But all the coils are open, the rotor is free to rotate. But A dash is energized, it is stick to the positions 1 and 4, or A dash is aligned with the rotor positions of 1 and 3. Now the S1 is opened, so we give the table for A is plus, B 0 and C 0, the rotation angle is 0 degree. Now S1 is open, so this is 0. S2 is closed, then this is plus and this is also 0. Now the B dash is energized, so it offering the low reluctance path, it moves 1 rotation or 1 step angle. So the step angle is 30 degree, so it moves 30 degree in clockwise direction. And next pulse is given to the C dash, then A is 0, B is 0, C is plus, the angle of rotation is 60 degree. And again the A is energized, B and C are open, that means switches S2 and S3 are opened. Again it is aligned to 1 and 3 with 90 degree of, that means 3 steps. So this is step 1 0 degree, step 2 is 30 degree, and step 3 is 60 degree, and step 4 is 90 degree. So each step is moving for 30 degree for each input pulse. Here this is the one phase on mode, that means at a time one pulse only given to the supply, another 2 phases are open. So this mode is called full step, but this is one step on. So the mode is A, that means the switching sequence is A, B, C, again A. The switching sequence is A, B, C, again A. This is the one phase on mode. And the next one is 2 phase on mode. 2 phase on mode means A and B, that is switches S1 and S2 are closed simultaneously. Then the rotor position is between the A and B. So it is aligned between the A and B. So the step angle is 15 degree. Then next sequence we on the B and C switches, that is S2 and S3, S1 is off. Then we get next step, that is 15 plus 30, 45 degree. Likewise next step we get 45 plus 30, 75, then 75 plus 30, 105. This is called 2 phase on mode. Then the sequence of the supply is AB, BC, CA and again AB. This is the full step mode, two phase on. And next one is off step operation. Off step operation, this is combined mode of the one phase on mode and two phase on mode. So initially the A is on, that is switch S1 is closed, B is open and C is open, that is S2 and S3 is open. Now the rotor teeth 1 and 3 is aligned with stator A and A dash, the angle of deflection is 0 degree. Then next we on the S1 and also S2 and S3 is opens. Now it is aligned between the A and B, so we get the half step angle, that is the step angle is 50 degree and half step operation, this is we obtain 15 degree. Then we get 15 degree, the sequence is AB and B alone and BC, C alone, CA and again A alone. This is called half stepping. The half stepping in the sense alternate of one phase on mode and two phase on mode. Then the sequence of operation is A, AB, B, BC, C, CA and A. And this movement is in forward direction or clockwise direction. If we want anti-clockwise direction in the sense, we have to move C, A, B, C. In the sequence we can give the supply to the coils, we can obtain the counterclockwise direction or anti-clockwise direction, or we can give A, C, B, like this is the sequence of rotation. And these are all the half stepping operations. Next one is micro stepping operation. So micro stepping in the sense we can use two phase on mode. In this two phase on mode, if the supply S1 is fixed as a constant and S2 supply is varied by the simple rheostat or resistance. So in this two phase on mode, both the supply are equal levels. It is energized fully, this is also energized fully. But in micro stepping modes, one is fixed as a constant. If A is plus, B is varies from initial value, that means low resistance, high resistance value to the low resistance value, then we can obtain the up to 0.18 degree stepping angle. From that we can obtain. This is called micro stepping operation. So the step, if we requirement is step angle is very low, that is less than 15 degree, in the sense we go with micro stepping operation. In another method is multi-stack, it is very low angle, that means very low angle, in the sense we go with multi-stack variable reluctance stepper motor. So this is the construction and working of variable reluctance stepper motor. This is working based on the reluctance, minimum reluctance path. So this is called variable reluctance stepper motor. So the next one is permanent magnet stepper motor. Next one is permanent magnet stepper motor. It is also your own stator poles, but the rotor is made up of permanent magnet material like ferrite material, and also the shape is cylindrical. The direction of rotation is depends on the polarity of the stator current, but in variable reluctance stepper motor, the direction does not depending upon the polarity of the stator current, but the permanent magnet stepper motor, so direction of rotation is depending upon the polarity of the stator current. So the merits and demerits of the permanent magnet motor is, it is do not require external exciting current, and also it having the high detent torque compared to the variable reluctance stepper motor, and also the permanent motor having the holding torque that is not exist in the variable reluctance stepper motor, and this is a high inertia and the slow acceleration. However, it has more torque compared to the variable reluctance stepper motor. So now see the construction of variable reluctance stepper motor. This is the number of poles, stator poles, that is 4. Number of stator poles, that is 4. Number of rotor poles is 2. Then we can calculate step angle, that is ns minus nr divided by ns into nr into 360. Then 2 divided by 4 into 2. Then we get 90. So step angle is 90 degree. So each step of input pulse, the desired angle of rotation of the shaft, that is 90 degree. Now if the coil, first we see the single phase on mode. So the A coil is energized, that is IA plus, and we include the A dash as a one phase and the B dash is a another phase. Now we give supply to the A dash, so the rotor is aligned with this north and south pole, so the angle of rotation is 0 degree. Now the A is de-energized and the B is energized. Now it is aligned with in this north pole, south pole, aligned with in this direction, and the stepping angle is 90 degree. Now again we give the negative supply to the A, so again it rotates 90 degree. We will give the 180 degree rotation, and if we give the negative current to the B, we get the 270 degree. Again we give the positive supply to the A, then we get the initial position of the rotor. This is a one complete circle of the rotation. So if the giving in the sequence to the stator pulses, that is A plus, B plus, A minus and then A plus, it rotates the clockwise direction. If we want anti-clockwise direction or counterclockwise direction, that means so A plus and then we give B minus supply, it rotates in anti-clockwise direction. B minus and then A minus and then B plus, A plus, it rotates in the counterclockwise direction. This is the one phase on mode. And two phase on mode, in the sense we give the supply to the both the coil, both the phases A and B. Now we tilt the centrally both the phases in this point, so it gives 45 degree. And next we give the negative pulse to the A and a positive pulse to the B. It take 45 plus 90, we get 135. Like each step we give the supply to the stator pulses, it rotates 90 degree angle. This is 90 means 360, again it rotates 45 degree. This is called full stepping in two phase mode. Next one is half step mode. In half step mode, one phase on, it is merging of one phase on and two phase on modes. So initially one phase is on, so the angle of rotation is 0 degree. Next is two phases are on, so we get the 45 degree, like 90. So the half stepping angle is 45, so 135, 180, 225, 270, 315, and finally we get 0 degree. So the incremental degree is here for half stepping operation 45 degree. So in this stepper motor also we can use micro stepping and also multi-stack. So these are all the construction and working principle of stepper motors. Thank you.